start the presentation. For anyone who's only just joining us, thank you for coming. I'd like to introduce our next speaker, that is Celine Parascam.
Yes.
Celine has a master's in materials engineering and entrepreneurship, is currently doing an MBA, so clearly you like studying, that's great. Has been in additive manufacturing for 7 years, started in a service bureau at Materialise, helping customers select the right technology for products, currently working at Solvay, helping customers to adopt high performance polymers in demanding applications, and also working closely with open printer manufacturers and service bureaus to qualify Solvay materials. So how you're going to fit that into 20 minutes, I don't know, but I will hand over to you and let you try. I'll switch my camera on when we approach 20 minutes, just so you know that's a kind of coming up on time. But without further ado, I will let you go ahead.
Thanks a lot, Candice, for the introduction. Indeed, she already said a lot, but I will be presenting and I try to summarize what I've been doing for several last months, just to look at how we could improve the performance of high-performance polymer and how to select and look at the printer's side. So first of all, let me just...
Sorry, everyone. I'm not quite sure what's happened there, but we've lost Celine, who I'm hoping is going to be back in any minute now.
Sorry for that.
There we go. Perfect. Welcome back. I was worried that I'd have to ad-lib for a minute, but that's good.
No, it's fine. I don't know why it was leaving the premise. No, I'm back. Let's restart it again. Yeah. So I will just... No, it's going well. So I'll do quickly the presentation of Solvay, what Solvay is doing, and what are the materials that we are proposing, and then going on the Solvay additive manufacturing side. So just pretty quickly, Solvay is a chemical company, like 60 years right now. It's like going and fuming about all the technologies. In terms of additive manufacturing, we are a small part of this big business. But what you have to know is that Solvay is present worldwide. We have printers at different places to do the test and pushing the materials further, and we are present in all the continents actually. The things, just to remind, where we are active on is really on the top of the pyramid. So if it's other materials, maybe on the commodities, we are not present there, but it's really on each time you need something really special for your market. Like I would say medical application, oil and gas, aerospace, where you need a lightweight, fire resistance, and all this performance, chemical resistance. This is where Solvay is active on. And that's in the business unit specialty polymer. So all the product that I will present afterwards is based on this knowledge and this know-how that Solvay has on the material side and on the polymer side. No, I think it's what we're interesting us the most today is on the Solvay additive manufacturing side. Let's say the materials on high performance, we mainly find them actually in our case on the FFF and on the SLS. Today, the presentation, I will really do it on the FFF because it's how to select the filament-based material. But just keep in mind that there are also SLS1, and it's a different type of technology and other type of request. But the FFF is the one that I will be looking at today. That's a slide that I like the most. It says really the 3 pillars that you need to make any good part or any AM part that you would like to see with good performance, good tolerance and everything. So what you have to always think is the material is playing a role, but the equipment and the design all together are making the part if it's successful, yes or no. So this is important that Solvay is definitely working on the AM material side. That's our core business, and that's the experience that we have and all the knowledge that we have built on the specialty polymer, even for injection molding. This is what we are working on. What we do as well is making that bridge to understand how we could perform better with the equipment that are on the market through partnerships with open printer manufacturer. That's what you see here. And I will especially spend my time on what we call Solvay printer evaluation program. I will explain what was the process and what we have done at that stage. We are also understanding that the design is a big part of it. With a good design, a clever design done for AM, this is really key and really important to make a good part. So let me go further to explain you what I've done. Just for the material side, to have a clear understanding what we have and what we will be discussing during the testing is measured in particularly these 3 materials, which are the really high performance ones, the PEEK, PEEK with carbon fiber with 10% carbon fiber, and PPSU. So all these three materials were tested with different open printer, and we have compared and checked the performance, how we could improve it to get the best results. All these materials, you could find them also in medical application with ISO 10931, right? But this is for now just the testing and mechanical testing at the moment. We have extended our portfolio for the future with new materials, but that's also the same concept of testing the materials. If the slide is moving. And this is two pictures that says all. Why you need to develop material dedicated for additive manufacturing. Simply because people are always coming to us and say, guys, we are using these materials for injection molding. We would like to do exactly the same path in additive manufacturing, but this is not the same technology. We all understand that injection molding doesn't have the same requirement as additive manufacturing. So what Solvay has been doing for the last years is really developing the best performance with all the know that we have, the best performance for these materials. Just as an example, this is two PEEK Cataspire PEEK materials. One is an injection molding grade that were taken from the shelves, making some filaments and then 3D printed it. You could see that it's not optimum, that the adhesion is not optimum as well, and then the results are kind of deceiving. The one that we developed and the one that you've seen before is really developed specifically for the extrusion for additive manufacturing. And that's how we could find better results, good adhesion, good performance, and a good part at the end. So we have to do our work on the material side, but it's also depending on all the other parameters. But this is the reason why we have a tailor-made materials. Just quickly, because you will hear it, it was said during Formnext, but you will hear it in the future. We have developed a new materials that is also based on like developing new materials, new concept. It's a new HPPA, so high performance polyamide. The idea was to have a polyamide type materials that has a HDT that is higher than the polyamide that we could find on the market today, but also being processable with a melting temperature that is accessible for lower hand printers. So that's two new materials. We could share information further, but this is important. So why key? It's key to develop materials specifically for additive manufacturing. Now, what interests us the most? I'm talking more on the manufacturing side, how to process the material. PEEK is definitely a challenging one. PEEK is definitely the materials that can be seen with warpage, with the lowest adhesion between the layers. You could see delamination, you could see difference in crystallinity, and it's really, really important to look at all these parameters and how to prevent that, having the right printer and getting the best performance. So it's not a plug and play system today. People are using different technology, different types of way of working, but this is definitely something to look at. And we are then making open discussion, partnerships with these open printers to improve the performance in both ways. For that reason, we have developed what we call the Solvay Printer Evaluation Program, in short, SPEP. So the idea was to help anyone on the market to understand what is needed and to perform with good performance the process of PEEK, especially for additive manufacturing. It's one view of testing it. Today, we started with mechanical performance, but there could be different criteria that you are taking into account when you select a printer. Could be the price, the size, all these different things. But first of all, the key and important factor to look at is to have a good adhesion between the layers. Without that, you don't continue further. So simply, we had asked the printers to print different samples, testing it in an iterative way. So we have asked them to print, we have tested on our side, making CT scan, checking the dimension, and then sharing the feedback to the printer manufacturer. We did few iterations, and as soon as we noticed that the value were definitely in a good direction, we were able to collect all these data and being able to share to everyone on the market would be interested to see what can be performed with PEEK material. So that was the process, just at the background. So you see it's pretty tensile bars that we have printed. And what we have seen, and I will showcase the value afterwards, is that the best result we have seen so far is to have a high heated chambers. When you have above 220, you secure the good adhesion between the layers. The performance can be also, and I was surprised by that result, to be honest, the first time I saw that, but we're close to injection molding or at the same level as injection molding. I was always sure it was 70% and we could not go above, but for this, it's pretty game changer, and it helps also to validate even more application on additive manufacturing. Then, just as a reminder, this document, so it's considered as a white paper, it has some reviews. So it's a living document, and the idea is to update it and expand it. So right now, we have already the version 2 that will be published in the next days. So this is just making sure that we are updating this value time to time and trying to get the best results with the value. And then we are only looking right now at the mechanical performance, but there are definitely other criteria to take into account when you select a printer. It could be repeatability or the testing that we would try to get this done as well to help you to select a printer. No, just this is a document I can share with you, or you could upload it on the sort of AEM shop. But this is kind of the value that we see. So how we manage that. So we did the test with different printers that they were open to test it. It's really an open test right now, and just to look at what can be the performance or the tensile that you could achieve. For just an example, for peak, the tensile test in the Z direction in injection molding as a reference is 91 megapascal. You could see that few printers have already achieved in the Z direction excellent results. All of them have high temperature chamber and master the parameters to make it work. With PCF, it's slightly different. You have to consider that the fibers will be orientated with the printing path. So this is important to consider, that the Z direction will be always similar to the peak value. And the epsilon or X direction, you could also play around a little bit with plus minus 45 degrees or completely orientated fibers. And for the PPSU, similar as this, you could have really value close to injection molding, even in the Z direction. All of these data are collected in a document and can be uploaded on our website. Nevertheless, feel free to contact me, and I will be free to share or exchange or respond to all the questions even after that call. On the design side, it's, as I said, there are the 3 pillars. So I wanted to just highlight this. This is for me something that is sometimes not always considered, or not people that are trained can consider it. And sometimes they are always thinking with the injection molding mindset. But just as an information, and that's something that can be helpful also for printing, is to understand what can be the challenges before printing. So you could reconsider the design and make it more successful after the print. So this is, we have done a partnership with Extreme. We have the materials law that is already developed for all materials that can help to save time prior to print and optimize the printing. So that's, for instance, a simulation that we already see what are the challenges or where could you have the breaks. So you could definitely help you with this, and then modify your path of printing, changing the infill and all these things up front to make sure you get the good performance. Another one, because we have done it, and I'm always happy to share this such example, because we always like to look at the case studies. But L'Oreal with Ultimaker and us, we have done a partnership to look at design and how important it is to consider the design. It was a contest with a lot of students and companies outside, where it was seen to put like a bottle holder that could secure like 5 different type of bottle together. And as you see, already the 3 first contestants have totally different design, different mindset, and all of them have different printing parameters to consider as well. So design is important. When I say the pillar, we have to close that loop and making sure that everything is going together right. No, just probably I went maybe too quick, but I will respond to all the questions. But what is important to understand here is that everything is fitting in a document, and then you could have access to it. And the idea is to spread the knowledge and the know-how that we have internally to help you to print these tricky materials, which are PEEK, PCF, or PPSU. So the first one is a printer evaluation program, the one that I have presented before. And this one is even how to start with it. Do you have to consider about drying the material? Yes or no? What are the temperatures? What are the conditions optimum for each material? That's important to know. And this is something that is available also for you if you have questions on this side. Because it can be, some things that you don't consider when you have the printer only, or before or prior to buy the printer, that you have to secure these steps before printing a good parts. No, I think I went on quickly, but you could see that I have my contact details for sure, and you can contact me at any time, where we can definitely look at question and answer, and I could deep dive in different topics.
And I think we would much rather you went under time than overtime.
Yes.
Otherwise, it's very awkward of trying to butt in and politely say, "Could you wrap it up now?"
Indeed.
So thank you for that. That was obviously very interesting. I'm more of a polymers person anyway, so I enjoy hearing all the polymers stuff. We have a question from someone in the audience. They've asked, how is the drying process for Solvay filaments different from the competition?
That's a good point. So it's for me, drying is mainly linked to the materials itself. So if I just take an example of PEEK or PPSU, the PPSU is one that is uptaking the moisture even more faster than the PEEK. So I will say it's more that every materials you need to have the drying process, but all of them you need to secure that everything is dry. Otherwise you see the stringings or all these issues. So let's say what we are making sure that it's possible is that the spools are secure to be dried at the same time as the material, and you don't have any issues with all this setup or all this setup. No, I can give you an example. So usually we advise to dry at 120 degrees during the night, or like taking the time to have it completely dry. I know that for PPSU, I also advise, and even for PEEK, but even worse for PPSU, that the printer have the drying system integrated. So you are making sure that there is no issues or no moisture picking up during the printing. And if you don't have that, making sure that you could have a oven type on the side that is feeding your machines and is securing that you have everything dry. Because this could fail your print, actually. If you don't have an dry enough materials, it could fail the print. But this is linked to the material itself.
And I think it's always quite interesting, those intricacies of the process, or what might or might not cause problems later on. We've got another question along a similar theme. What's the best filament dryer you would recommend for Solvay high performance materials, if you're allowed to recommend one?
I mean, I don't have a preference, but I will say, my preference would be to have a machine that has the system integrated first, also because for the print, I think it's the easiest way. So I'm pushing the printer manufacturer to integrate it, so everything is all together. That's definitely true. Then having a dryer in the system. I mean, as soon as you are securing that it's you can heat it up to 120 in a consistent manner, and then the moisture is not there anymore. That's good enough. Sometimes people are strangely taking really cheap system. It works perfectly fine. It's just like as soon as you are sure that you have this setup, that will be clear. But I must admit, I would be preferring that the printers would integrate it in their printer, such drying system too. Not prior to the print, but during the print, that's for me important that it stays dry.
Okay, I'm sure we may have a few participants in the audience from printer manufacturers, maybe. So please listen. That's your request from Celine. Incorporate that into your systems.
No, but I mean, it's it can be, but I must admit, with one of our printer, we also work different way. Like we had the oven type on the side, and it works also perfectly fine. So you can compensate what you have, and sometimes it works fine. It's just like you have to understand that you could have stringing and you could have issues if the moisture is picking up during the prints, especially for PPSU. You will directly see it.
Yeah. Okay. I have one question in a minute, but we've got another question from the audience. Do you have any experience modifying Ultimaker 3D printers to print high performance materials? If yes, what did you learn? So I guess the question there is, can we use these high performance materials on, I don't want to say less high performance, but maybe less high performance?
No, I agree. I mean, one of the materials that you might have seen during the presentation is the PVDF. The PVDF is requiring 230 degrees for the nozzle temperature. So this is perfectly fitting with Ultimaker, and this was set up with also the printing profile, and everything is set up. So I will advise for the PVDF, that's the best way to go. Ultimaker fits, it's definitely perfect, and that's why we have it at 2.85 millimeter. We really wanted to have a secure system that everything is going well. Now, on my side, I must admit the nozzle temperature for peak is 420, 430, 440, depending on the printer. And even though Ultimaker cannot achieve that temperature. So melting the peak PPSU, you should forget it. I know that some people are tweaking a bit after, but you can't achieve that temperature anyway. So that for this reason, I will, it's impossible for these three materials. For PVDF, perfect. For the other three, it will never be possible, or maybe not achievable for the Ultimaker.
Okay, I've just noticed a quick question in the chat asking to clarify, did you say 235 or 285 degrees C? Just a minute.
235, even 230, 235. Yeah, but the diameter size is 285 millimeter, because generally you have 175 for the majority of the machine, but the diameter is 285. But the temperature of the nozzle is 230, 235. Yeah.
Perfect. And we have just a couple of minutes left. I'm gonna ask perhaps a slightly more broad question, because I was really interested reading your bio of all the kind of, I guess, your journey to get here. But in particular, you mentioned working at Materialise and kind of advising people on what printer to get.
Yeah.
How was that? Was it a bit of an uphill battle? Did you find that people didn't really know what was going on when they came to you, or kind of how did that work? And what were perhaps some of the common things that you ended up having to talk to people about?
It's still struggling today, I must admit. This is still the same question, but I believe that when people have a part in their head, either it's a part that is for injection molding, either it's a part for another technology, and they come exactly with the same design, and they want to have it quickly, and they want to do everything the same. But you have to kind of teach a little bit that says, I think there are clever ways to do your part. If we could change, if we could modify it, it's even better, cheaper, lighter, and you could definitely take best part of it. So it's always, and it's still today in my job, like fighting the question back, is it needed? Is it something that is must have or nice to have? Like today, all the question could be like peak printing. As it's FFF, the surface quality is not optimum. And if you compare it to machined CNC, definitely you don't have the same surface quality. What you could still do is make a neonet shape part in additive manufacturing and still do the CNC afterwards. It just, is it needed? Is it a must-have? Is it like for your application, actually, the surface layer with a smaller nozzle, is it better? Yes or no? So for me, it's always to find this compromise and say, what is key? What is a must-have and what is a nice-to-have? And then making sure that in terms of expectation, we are not going to a crazy moment. Like SLS, FFF is different, and every technology has its own advantages. And you have to keep that in mind and pick the best. Because for me, if you don't pick the best technology first, you will end up to anyway change it afterwards. So you make double works before going to the final decision, which is, I don't know, another technology that you would like to take.
Yeah, I completely agree with that. Just the idea of designing for something when you don't know what process you're going to use is difficult, but equally kind of, I like your point about the modifying the design and working out what you absolutely have to have, which I think ties in quite well with, I guess, all processes and all materials. That kind of transcends all of them, if you like.
True. One experience that I had is that you have software that were definitely nice, that they can make the drawing in an automatic way. So they could say, this is the tolerance. And then you think that all the tolerance were achieved only by technology like CNC or injection. And they give you these tolerances and you say, this is not the same technology. You cannot use the same drawing. So you cannot compare this from what it's really some, and if the designer is thinking sometimes it doesn't remember why we have to have this tolerance, and is it needed, must have, can we compensate it in another way, but it happens. Yes, definitely.
For sure. I could carry on having this conversation for ages, but we have our next session of the chat is coming up in a couple of minutes. So I will very unceremoniously remove you from the stage.
Perfect.
And then bring up our next speakers. But thank you very much. It was really interesting talk. Again, everyone in the audience, I guess, catch Celine at one of the networking sessions if you see her, or do get in contact. But I know there's not always time to answer millions of questions during these.
No, that's perfect.
Brilliant.
Thanks.
Thank you very much, Celine.
Thank you as well. Have a good day.